Hello everyone, good evening. Am I audible? Yeah, चलो start करते हैं. Let's start. Just 1 second. Okay, quickly tell me if I am audible. Then we'll start. So, what have we covered in the last two sessions? We started with a basic introduction, right? Ki in the last session we covered what is the definition or basically the scope or the objective of thermodynamics. Yes, this is what we covered, objective of thermodynamics. We started with this. Yes or no? After that we covered, sir, so what is thermodynamics? To analyze the change in the system or the properties of the system when energy interaction is happening. Okay, by thermodynamics, heat that is causing the motion, and because of that motion, what are the change in properties of the system? So when you analyze that, that is called as thermodynamics. So that comes under the scope of thermodynamics. Okay. So whatever change we see in the thermodynamic system, we have to analyze that. Now there are two ways of analyzing, two approaches of analyzing. One is microscopic approach and the second is macroscopic. ठीक है? This is also we discussed, yes or no? This is also we discussed. Sir, what is microscopic approach? What is macroscopic approach? So microscopic approach is when you talk about individual behavior. Individual behavior. And macroscopic is when you talk about average behavior. ठीक है? Now based upon that, we have talked about concept of continuum. When the concept of continuum is valid. So here we have discussed if your Knudsen number is less than 0.01, then you can say concept of continuum is valid. Yes or no? Do we remember this? This is what we discussed in the last class. Then finally, we ended that session with the definition of system, surrounding, boundary, and universe. हाँ, ठीक है? This is what we covered in the last class. Okay. So now we are going to move forward and we are going to see what are the different types of system or different types of thermodynamic system, to be more specific. ठीक है? चलो. Before we start, let me give you a brief introduction about myself. So I have 6+ years of teaching experience. I have taught for GATE, ESC, PSUs, AE and JE exams as well. I have done MTech from IIT Kharagpur. I have done MSc from Politecnico di Milano, Italy. 3.5 years of industry and research experience, few research publications, national as well as international. And my area of expertise is basic and applied thermodynamics and heat transfer. ठीक है? चलो. And as you guys already know, foundation batch is going on. So keep joining this and already your strength of material is done. I am taking thermodynamics and then fluid mechanics will start. And I think Chandrasekhar sir will take this. Okay. So keep tuning in till the end of this series. If you have not joined my Telegram channel, do join the Telegram channel. So either you can search by name Mechanical by Vipin Yadav or you can scan this QR code. You will be joined in the Telegram group. All my schedule, all my PPT, everything is shared in that Telegram group and that is the only way that you can communicate with me, okay? If you have any doubt. Chalo, let's start. So that day we discussed, sir, what is a system? So system is basically something that you focus on, right? There is no fixed system. There is no fixed system. For a eye doctor, eye is the system. For a heart doctor, heart is the system. So basically system is what you focus on or at what portion of the whole universe. Okay, if this is your universe, and there can be infinite number of systems here. Okay, now if you want to focus on this part, this portion, then this is your system. If you want to focus on this part, then this is your system. Everything else is surrounding. Similarly, if you want to focus on this, this is your system. Okay, or let me write it like this. Let's say you have infinite number of systems, system 1, I mean let's not call it system, but it's some entity. Okay, 1 2 3 4 5. So right now if you want to focus on number 1, then 1 is your system. Everything else yani ki 2 3 4 5 and 6. So 6 is what? 6 is this part. 6 is this part. Okay, so everything else is what? Surrounding. Similarly, at some other time, if you want to focus on 2, then second is your system. Everything else 1 3 4 5 6 is what? Your surrounding. So it depends on what you want to focus on what portion of the universe you want to do study or you want to analyze. That is your system. If you want to analyze the whole universe, मान लीजिए, so if you want to analyze everything, that means 1 2 3 4 5 6, then the whole universe is your system. Sir, universe you are saying system plus surrounding? No. If you want to analyze everything, then universe is your system. There is no surrounding. That's all. Okay. So again, keep an open mind about the definition of system. System is nothing fixed. System depends on what portion or what kind of study you want to do. First thing. Okay. Chalo. So, because why I focus on the definition of system so much? Because a lot of students remain confused about how to define a system and they become very rigid. If you decide one thing as your system in this question, in first question, there may be a chance that in the second question that is not your system, that is your surrounding. Okay, it can very well happen. So keep an open mind about system, first thing. Okay. Second thing is, let us say this is my system. Okay, this is one system that I have chosen, and everything except system is surrounding, and this is boundary. Now system and surrounding want to interact. Now what do you mean by interact? That means something has to happen, either a conversation. For example, if I am sitting in this room and someone is sitting outside the room, so if this room is your system, so I am inside the system and some person is outside the system. So if I want to communicate with him, so either communication can happen either in terms of I give him something. So if I give him something, I have that thing, whatever I want to give, it should cross the boundary. Or if I want to interact with him in the form of sound, so my sound should go outside. So in a simple language, you have to understand that whenever system and surrounding has to interact, so that interaction must lead in crossing the boundary. Yani boundary must cross. Whatever interaction is happening, boundary must cross. If boundary will not cross, you will not say that the interaction has happened. Okay. So interaction can happen in two ways. Mass transfer or energy transfer. Now see, by surrounding also has some mass, right? And system also has some mass. So either some mass is going from the surrounding to the system. So yani ki we can say mass is entering into system, or let us say some mass is going out, mass is exiting the system. So this is called as mass interaction. This is called as mass interaction between system and surrounding. But remember one thing, whatever transfer is happening, यानी कि mass is going from system to surrounding, that means you will only say mass transfer has happened or mass interaction has happened if it is crossing the boundary. If a mass is going from here to here, you will not say mass interaction is happening, because it is only happening inside the system boundary. No boundary is crossed. Similarly, if mass is going from here to here, again it is not crossing the boundary. So unless it is not crossing the boundary, you will not say transfer has taken place or mass transfer has taken place. ठीक है? First thing. Second is energy transfer. Energy transfer यानी कि energy transfer can also take place. यानी कि either some energy is going in or some energy is going out. Some energy is going from the system to the surrounding or from the surrounding to the system. ठीक है? Again, energy transfer must happen in a way that it is crossing the boundary. For example, if you take simple example, for example, this is a container, okay? And let us say here I have a grate kind of thing in which I have put down some coal. Some coal I have put down. Now I am burning this coal, okay? I am burning this coal. I am giving some heat, some fire, and this coal start burning. So when this coal start burning, what will happen is heat will get released and that heat will enter into the system. This is your system. This heat will enter into the system. Okay. So you can very clearly see that heat is crossing the boundary, energy is crossing the boundary. That time only you can say energy transfer is happening or heat transfer is happening. Let's take one more example. This is your system. Right now the grate is inside the system. The grate is inside the system. Okay. And then you are burning it. When you have burned it, so heat will be released and heat will come here. Now you can very clearly see in this case no heat transfer, or you can say no heat is crossing the system boundary, and therefore you cannot say that heat transfer is happening. Okay. Now in the second case, heat is crossing the boundary. So in this case, heat is crossing the boundary and you can say that heat transfer is happening. Is it very clear? Because a lot of students remain confused till the end. Sir, how heat is getting transferred? You have to see, you have to look at the boundary. Okay. If this is crossing the boundary, okay, heat transfer is happening. If it is not crossing the boundary, heat transfer is not happening. Is it clear? Yes. So again I will tell you, when you say this energy transfer is happening, energy transfer you will only say when it is crossing the boundary, when it is crossing the boundary. Now this energy transfer can happen in two ways, either heat transfer or work transfer. Heat transfer I have shown you already the example, this one. Work transfer we will also see later on, but this energy transfer can happen only in the way of heat transfer or work transfer. Okay. So this energy transfer, क्या रिपीट करूं बाबा, क्या रिपीट करूं बताओ? रिपीट क्या, जो 15 मिनट से बोल रहा हूं सब कुछ रिपीट कर दूं? है? बताओ तो सही, क्या रिपीट करवाना है? दिस एनर्जी ट्रांसफर will take place in the form of heat or work. Understood? ठीक है, चलो. Now how this heat transfer is happening, how this work transfer is happening, we will keep seeing. अभिषेक, ये वाला क्या बाबा? What is ये वाला? If I have told you something, you say it in the you have this thermodynamics is a technical subject, right? So use a technical term. Ki sir, explain what is heat transfer, what is work transfer, explain why you can say boundary is crossing. ये वाला वे वाला क्या होता है? What is ये वाला वे वाला? Nothing, right? So use a term. कि sir, explain this concept. Okay? ये वाला वे वाला कुछ नहीं होता है. You said the same thing again. ठीक है? चलो. Now just say कि what do you want me to explain? I'll explain. Okay, but be specific. I cannot explain what I have been seeing for 15-16 minutes. Okay, boundary. So you want to understand this point, huh? Okay, so it is very clear. Look, what I have been telling you is कि whatever you will say, whenever let me explain this again. Okay, chalo. So see, you can only say mass transfer or energy transfer has happened between system and surrounding if it is crossing the boundary. Otherwise you cannot say. So the example I gave you, take a system. This is your system. Okay. Now in this case, what is happening is I have a grate here. Grate means is over which we can put coal, right? Or fuel, whatever. So we burn fuel over this, okay? And it has some coal over here. Now I will supply some, ignition method and I will start burning this coal. And when you burn coal, I mean, you know all this, कि whenever coal is burned, heat will be released, right? Chemical energy will be released. So that chemical energy will be converted to heat basically. So this heat will be added to whatever is there in the system. If the system has water, so that water will absorb heat. If the system has air, then air will absorb that heat, okay? So this heat will be released in the system. But can you say heat transfer has happened? No. Why? Because heat is not crossing the system boundary. This is your boundary, you see. This is the white boundary. This is your boundary. So heat is released. Heat is added to the system. But that heat transfer has not happened because it has not crossed the boundary. You can take another example. This is your system again. And now this is your grate. Grate is outside the system. Over the grate, I have coal. Now again I will supply some air. I will start burning it by using some ignition method. And when I will burn it, heat will be released. And over that I have put a vessel. Over the coal I have put the system. Over the coal I have put my system. So this heat will be entering inside the system. And you can very clearly see, if you look at the boundary, this white thing is the boundary, right? This white thing is the boundary. So very clearly you can see that if this is the system boundary, coal is here, coal is outside the system, and heat is entering inside the boundary. So heat is crossing the boundary. Heat is going from one side to other side of the boundary. So unless heat is not crossing the boundary, you cannot say heat transfer is taking place. So in this case, no heat is crossing the boundary. In the first case, no heat is crossing the boundary. So you can say no heat transfer. But in this case, in the second case, heat is crossing the boundary. So you will say heat transfer is happening. Heat transfer is happening. So you always have to look at the system boundary. Ki, is it crossing the system boundary? If it is crossing, yes, heat transfer is happening or energy transfer is happening. Okay? So this energy transfer can either take place in heat form or work form. Now in more detail how work transfer, what is work transfer, we'll see that later. We have a complete chapter of work transfer and heat transfer. But right now just understand that this heat transfer will only take place, this energy transfer will only take place in the form of heat or work. ठीक है, चलिए, तो what I have told you कि the system and surrounding can interact either in the form of mass transfer, either it is mass transfer from system to surrounding or from surrounding to system, or energy transfer from system to surrounding or from surrounding to system. Okay, now based upon the interaction, system can be classified as closed system, open system, isolated system. Closed, open and isolated. And based upon the state of system, state means, sir, is it solid, liquid or gas? We classify our system as homogeneous or heterogeneous. Okay, so let's try to understand them one by one. First is closed system. Closed system. See, this is my system. Now, I already told you we have classified this based upon the interaction. Now, system and surrounding can interact only in two ways. What ways? Sir, mass transfer, either mass in or mass out, or it can energy in, energy out. So either in two ways, either mass form or energy form it can interact. Now when I am saying closed, so earlier my system, this room is my system, okay? And earlier, I mean, in general, I can only allow mass or energy transfer. But I am saying closed, closed, closed. That means I have closed my system to one of the transfer, one of the interaction. And what is that? Mass transfer. You will not allow mass to enter or mass to exit. You will not allow any mass to enter or exit. Okay, so let us try to understand it one more time. ठीक है, चलो. So how will a closed system? So a lot of students will say, sir, if you are not allowing any mass transfer, then how system can have mass? So just assume a case of your pressure cooker. Okay, so this is your system. Now I have filled some. This is your system. Okay. Now I have filled some mass in this. Let us say mass I have filled 10 kg, and then I have closed it basically. First I have filled 10 kg, then I have closed it. From now on, I will not allow any mass transfer. यानी कि no mass can enter, mass cannot enter. That means mass in will be 0. No mass can go out. Nothing can go out. So mass out is also equal to 0. Mass cannot enter, mass cannot go out. So tell me, if this container has 10 kg mass, now I am not allowing any mass to enter or go out, then how much mass will this system have all the time? This system will always have 10 kg mass because I am not allowing any mass to enter or any mass to go out. This system will always have 10 kg mass. That means it is a fixed mass system. It is a fixed mass system. Mass of the system remains same. So you can also say fixed mass system, because mass, once it is entered, after that, once whatever you have done, you have done. But after that, you will not allow any mass transfer. So mass is fixed. But energy transfer can happen. Energy can go in. Energy in is not equal to 0. And energy can go out as well. Is not equal to 0. Okay. Now this energy transfer can either take place in the form of heat or in the form of work. Okay. Similarly, this one can also be in the form of heat or work. Okay. Now, so no mass interaction, but only energy interaction. So a system that will not allow any mass interaction, but only energy interaction it will allow, it is called as fixed mass system or closed system. May take place between system and surrounding through the boundary. It is also called as non-flow. Why non-flow? Non-flow in terms of mass, because mass is not flowing, so it is called as non-flow system. Okay, I already told you mass of the system remains same, but the volume of the system may or may not change, again flexible boundary. Now a lot of students remain confused about this. A lot of students remain confused about this. Sir, if mass is not changing, how volume can change? Of course it can change. You see, take a cylinder. Take a cylinder. Fill it with some mass. Let us say mass you have filled 10 kg. So 10 kg gas you have filled in this. And once you have filled 10 kg gas, then close it with a piston. Close it with a piston. Okay. Chalo. So what is my system, Baba? This boundary, yellow boundary is my system, because I want to analyze the behavior of my gas inside the system. So right now there will be some pressure P1, volume 1, temperature T1, mass is 10 kg. Okay, density will also be there, something will be there. Okay, fine. Now what you do is, let us say you supply some heat to the gas from outside. You are only doing energy transfer. Okay, no mass is entered, only energy you have given inside the system. Now when you give this energy, what will happen is, this gas, blue molecules of gas will absorb this energy. So the kinetic energy of the molecules will increase. When these molecules will absorb heat, their kinetic energy will increase. They will start moving randomly. When they start moving randomly, then what they do is, they start hitting the system boundary everywhere. So these molecules, should I draw a different diagram? Okay, let's do it here itself. So when the molecule kinetic energy will increase, these molecules will start hitting the boundary everywhere. All the molecules will start hitting all the boundaries, this side, this side, this side, all the boundary it will start hitting, because it want to move. It has more energy now. When you have more energy, you want to move here and there. So these molecules want to move, and when they want to move, their momentum will increase, and they want to move, and but you have a boundary here, so it will hit the boundary. It will hit the cylinder boundary, the piston boundary, everywhere it will hit. So when it will hit, it will create a force. It will create a force on the system boundary, which is cylinder, also piston. But cylinder boundary is fixed. I already told you two types of boundary are there, fixed and flexible. Now cylinder boundary cannot move, but piston can move. Piston is free to move. So what will happen is, because of the heat that you have given and the kinetic energy of molecule has increased, it has pushed the piston forward. So your piston will come here. Your piston will come here. And now when piston will come here, so the same gas, you see, you have 10 kg gas. Gas has not entered, but the same kg gas will start occupying the whole volume, this volume. And now what color should I use? Okay, now the system boundary will be this one. This is your system boundary. So as you can say, by iska pressure will also change, volume is increased, V2, temperature will also change, but mass remains 10 kg itself. Mass remains 10 kg itself. So you can see here, a lot of students remain confused. Sir, if mass is not changing, how volume can change? This is how it can change. The same volume can expand. The same volume can expand, or it can be compressed as well. If you give a work from outside, if you give some, come and push the piston inside, then volume will decrease. but mass remains same. So mass can be fixed, but volume can change. Volume can change. Okay, chalo. Now what is the example? Piston cylinder arrangement without valve. Without valve. Okay. Now we can have adiabatic boundary and rigid boundary. So rigid boundary is what? Rigid boundary is a boundary that cannot move. A boundary. So that means for rigid boundary, change in volume is also always equal to 0. Volume cannot change. Volume cannot change. And for adiabatic, heat transfer is always 0. I am just giving you some terms, but we will study that in very detail. Very detail. So you see, if this is your system, and this system will not, if you insulate the boundary, so when you insulate, that means it will not allow any heat transfer. It will not allow any heat transfer to go in. It will not allow any heat transfer to come out. So insulation is a very, a practical method of reducing heat transfer. Okay. So even in, in your refrigerators, in your ACs, insulation is a very critical portion. Okay. Because you see, in your refrigerator, inside temperature is 5 degrees Celsius. Outside temperature is 25, let us say. So always heat will try to come inside. But because your refrigerator is insulated properly, so we can assume, it is not true, but we can assume that this heat transfer is 0. Because earlier a lot of heat will keep flowing. But if you insulate it, then it will reduce the amount of heat transfer. It will not be 0, of course. Just I am giving you a value. Ki if you have done a perfect insulation, then what will happen is you can reduce this to 0. So you can say adiabatic. So how is this boundary? This is adiabatic. A boundary that will not allow any heat transfer is called as adiabatic boundary. And rigid boundary is boundary that volume will not change. Now it will not allow any exchange of work, that we'll understand later. But right now just understand, if the volume of the boundary cannot change. For example, this volume is constant. Whatever you do, volume will remain constant. But here, volume is not constant. Volume can change. So this is basically rigid boundary. This is rigid boundary. This is thermal. This is flexible boundary. Okay. So I hope the concept of closed system is completely clear to you. Now let us move on to open system. Sir, what is open system? So open system is, look, in closed, there, okay, again I'll write it like this. This is your system. And this is your surrounding. Now only two types of interaction can take place. Either mass interaction or energy interaction. Now in the closed system, I did not allow mass to enter. In the closed system, I did not allow mass to enter. But so that means you can say the boundary was closed for the mass, but if you open the boundary for the mass, then it is called as open system. That means mass can also flow inside, mass can also flow outside, energy can also flow inside, energy can also flow outside. So when both the interactions are allowed, mass as well as energy, then you can say it is open system. It is open system. Okay. Now, energy as well as mass interaction may take place between the system and the surrounding through the control surface. So in this case, look, this is boundary, right? But sometimes we also call as boundary as control surface, because let us say, look, It is a 3-kilometer pipe, let us say, and water is flowing here, and you want to analyze how the properties of water is changing. So what you do, you will not do the analysis for entire 3-kilometer pipe. You draw a control surface like this, and then you see here, you can very clearly see mass is entering here, mass is entering, okay, mass is going out. Similarly, maybe some, some heat transfer is happening here, that means energy transfer is also happening. So mass is also happening, energy is also happening, means open system. So this is the open system. If you call this a system, it is the open system because it is allowing mass to enter, mass to go out. And this type of systems, instead of boundary, sometimes we call it control surface as well. So boundary and control surface are almost the same thing. It is just a control surface is a surface through which volume does not change usually. Okay. So focus is on the definite volume enclosed by the control surface. Okay. Sometimes referred as control volume system. That means volume is not changing. Volume is not changing. But why I am saying sometimes? Because volume can change as well. I'll tell you how volume can change, but it can change. Okay. And it is a flow system. It is a flow system. Okay. What are the examples? Condenser. So basically most 99% of your power plant equipments, condenser, turbine, boiler, okay, compressor, nozzle, diffuser, heat exchangers, they are all open systems. 99% of your components are open system. Okay. Because why it is open system? Because you need some output. So continuously mass flows in, something you are doing on the mass, and then continuously it is going out. Okay. Chalo. Now, when you talk about open system, so open system can be classified as steady flow and unsteady flow. Steady flow and unsteady flow. Sir, what is steady flow? So let me tell you what is steady flow. See, this is your system, let us say. Okay. Now, initially it has mass, So let us say M1 is 15 kg. This is the mass. And it is an open system. Okay. It is what system? Open system. That means it can allow some mass to enter. So let us say some mass is coming in. In means I. So let us say 20 kg per second mass is entering. Okay. And 20 kg mass is going out. Continuously it is happening. 20 kg per second mass is continuously going out. So mass in is equals to mass out. Simply you can see an example. Let us say you have 15 rupees. You have 15 rupees. Okay. Now I give you 20 rupees and I tell you to go and give it to someone. So I gave you 20 means money in is 20 for you. If you are the system, you are open system, so I can give you money. Okay. So you already have 15 rupees in your pocket, but I give you 20 rupees and I tell you to give it to someone. So for you 20 rupees came and then 20 rupees went out. So now how much mass do you have finally? After this transaction, how much mass do you have finally? Again the same mass, which is 15 kg. So as you can very clearly see, if mass in is equals to mass exit, then M1 is equals to M2. That means mass will not change, fixed mass. And that is called a steady flow. Steady means whatever mass is coming, same mass is going out. Steady flow. So this is basically the definition of steady flow. So I can say what is the change of mass of system, यानी कि सिस्टम के मास में कितना चेंज आया है. So already system has 15 kg, still it has 15 kg. That means it already had 15 kg. Now even after the transition it has 15 kg. So what change? No change. Nothing has come. So when change of mass of the system is zero, it is called as steady flow. The same thing we can do with energy. Okay. So it has some energy E1, and whatever energy you are giving, energy in, will be equal to energy out. So if energy in is equals to energy out, means change of energy of system is equals to E2 minus E1 is equals to 0. There is no change of energy of the system. So these type of systems are called as steady flow system. That means whatever is coming, same is going out. So it is not changing the state of system. So whatever you see at any point of time, you can come. At any point of time you can come and you can see the state of the system. It will not change with respect to time. The state of the system will not change with respect to time. Why? Because whatever is coming, same is going out. Okay. So that is called as steady flow systems. I hope it is clear. Next is unsteady state. Unsteady state. Now what does it mean? It means, let us say it has 15 kg mass, okay? And whatever mass is entering, let us say 20 kg per second is entering. And how much mass is going out? Let us say 5 kg per second is going out. So how much mass will increase in the system? By enter हुआ 20, exit हुआ 5, so 15 extra was added. That means it will be 30 kg. Sir, what are the examples? Example you can very common example you can take. You go to your bathroom, right? You go to when you go to for a shower, you open the tap, right? You open the tap. Now when the bucket is filling, look, right now bucket is completely empty. Okay, this is your bucket. Right now bucket is completely empty, means M1 is equals to 0. Now you open the tap. So some mass is coming. Let us say 20 kg per second mass is coming. And let us say you are also taking some out, little less. When you are filling the bucket, you don't take much out, right? Once in a while you will only take one mug out or something. So what you are taking out is 5 kg per second. So that means 15 kg per second is added inside the bucket, and therefore the level of bucket is going to increase. The water level will going to increase. That means change of mass of system is not equal to 0. Simply I can give you this example, bucket example I have given you. One more example I can give you. For example, if you have 10 rupees, you have 15 rupees, let us say, and I give you 20 rupees, and I tell you to give 5 rupees to someone else. So what will happen with you? You will increase with 15 rupees. Earlier you had only 15 rupees. Now you have 30 rupees. Because 15 you have kept with yourself. So when mass in is not equal to mass out, you are either giving more mass and less mass is going out, or you are giving less and more mass is going out. These kind of problems are called as unsteady flow problems. Unsteady flow problems. So I can write it like this. If mass in is not equal to mass out, then you can say unsteady. And change of mass of system is not equal to 0. You can see there is a change in the mass of the system. Similarly, if energy in is not equal to energy out, so you and change of energy of system is not equal to 0. So these type of systems are called as unsteady. Now we spend a lot of time, okay? A complete class of 2 hours class is on steady state. Then a complete 2-hour class is on unsteady state. So we'll understand that in much detail when we go into that topic. Okay. Abhi to I have just given you a very brief introduction about what you can understand if you see the word steady flow and unsteady flow. Simply, nothing more. It is not I have like explained you these topics. We will explain that. We'll do many examples. We will see the derivation of steady flow, unsteady flow. We will go with practical examples of this, and we will do numericals on this. Okay, complete 2-hour class on steady flow, then 2-hour class on unsteady flow. We will have it. Okay. But now we can move on to the third type of system, which is isolated system. So we have 3 types of system. Closed we have seen, open we have seen. Now third one is isolated system. Now what do you mean by isolated? You see, if I want, I think you may have seen now seen this word isolated. Okay, so what is isolated? Isolated is something that I don't interact with anyone. So if I say that like Saurabh is an isolated guy, matlab Saurabh does not interact with anyone. He does not talk with anyone. He does not play with anyone. He does not eat with anyone. He is a very isolated guy. Means he does not care about anyone. He does not talk to anyone. Does not interact to anyone. So a system that does not interact with anyone in any way, it is called as isolated system. Okay. So let us say this is my system, and if it is not allowing any mass transfer, mass in is 0, mass out is 0, energy in is 0, energy out is 0. That means no mass transfer is allowed. Basically, it is not interacting. It can only interact mass or energy way. It is not even allowing mass to interact. It is not even allowing energy to interact. That means this kind of system is has nothing to take with its surrounding. I do not care what is my surrounding doing. So this type of system is called as isolated system. So as you can see here, it is a fixed mass and energy system. Fixed mass and energy system. यानी कि सिस्टम का मास ऑफ सिस्टम will not change. Whatever mass is there remain fixed. Why? Because no mass is entering, no mass is leaving. Similarly, energy of system will not change. यानी कि no energy is entering, no energy is leaving. Whatever the energy inside the system, it will remain conserved, it will remain same, it will not change. So tell me, can you give me an example of isolated system? A system that mass and energy is always remains same, remains constant. So if mass remains constant means mass conservation, energy remains constant means energy conservation. So do you know the name of any system that allows mass conservation and energy conservation? What is that? Universe. You see, the mass of the universe will always remain constant. The energy of the universe will always remain constant. The energy of the universe, or you can say energy cannot be created or destroyed. It can only be converted to one form to another. The total energy of the universe will always remain constant. That means when we started, like for example, we started 10,000 years ago. So the energy, the total energy that was there, it is still same. The amount of energy, if you talk about the amount of energy that was there 10,000 years ago, is same as the total energy that we have today. Sir, then why do we keep saying energy resources will deplete, energy, we should save energy, we should do this, we should do that? Because the total energy will remain conserved, but energy conversion is happening. For example, chemical energy is converted to heat energy, mechanical work is converted to heat energy, okay, kinetic energy is converted to potential energy, coal is what? Chemical energy basically. Okay, chemical energy is converted to heat, okay. So nuclear energy is converted to some other form of energy. So now what is happening is that we are converting, when we are using energy, then energy is converting to a useful form of energy to a useless form of energy. Because you see, heat we cannot use after a certain point. We can use heat, but you see, look, I am rubbing my hand. You see, I am rubbing my hand. If I rub my hand for 2 minutes, my hands will get warmer, right? And my hand will get warmer, means there will be some heat released from my hand. But can you use this heat? No, you cannot use this heat. You can only use heat which is coming out at very higher temperature. For example, in the boiler, heat is coming out at 1000 Kelvin. So you can use that heat. But this heat, you see what I have done, I have used the chemical energy of plants. Chemical energy was of plants, right? By food gave us chemical energy. That chemical energy was converted to metabolic energy. That metabolic energy is converted to heat right now. And this heat is gone now. I can't do anything with this heat. This heat that I have just removed from my metabolic energy, I had that energy, but when I did this, I utilized some of my metabolic energy, and that energy is converted to heat and now gone to surrounding. Now understand this point, that this heat which is gone to surrounding, it can never be utilized. You cannot use that energy. So now there is some energy that is added to universe that cannot be utilized. So what we are doing here is, total energy will remain conserved. Yes, total energy will remain same even after 10,000 years later. But when we are doing any process, whatever we are doing, we are running power plants, we are running steam engines, we are running, heat engines, we are running ACs, refrigerator. So whatever we are doing, we are converting a high quality energy or a useful energy. We are converting useful energy to, we are going towards useful energy to a more useless energy. And there will come a point in time that all we have is useless energy and we cannot use that. We have the same amount of energy but useless. We cannot use that. And that is why we say we have to conserve energy, we have to save energy, we have to basically use less energy as possible. Okay, chalo. The example is either universe or thermoflask. Thermoflask is also, you see, thermoflask. Once you put hot coffee, let us say hot water you put here. Now, normally if you have a plastic bottle and you put water, let us say at 100 degrees Celsius, outside is 25. Now, after let us say 30 minutes, because continually heat will go out, after 30 minutes, you will see that inside here is also 25 degrees Celsius. But if you take an example of thermoflask, so let us say in the morning, I have poured some hot water of 100 degrees Celsius. Outside is 25. Even after 12 hours, I will see it will, let us say, reach some, let us say 70 degrees Celsius. That means this heat transfer that is happened is very, very less. So you can assume is almost equal to 0. So you can see here mass in is not allowed. Mass in is equals to mass out is equals to 0. Energy in. So heat out is also 0. Almost equal to 0. So you can say, okay, it is an example of isolated system. Isolated system. Okay. Got it? Chalo. Now, next is based upon the state of system. Based upon the state. What do you mean by state? State means phase. State means phase. Sir, what is phase? What is phase? So phase is a quantity of matter which is homogeneous throughout its chemical composition and physical structure. Homogeneous throughout its chemical composition and physical structure. Now, what does it mean? Let us say H2O. See, if you have water, you have, let us say you have system and there is some water here. It is completely filled with water, okay? Now, anywhere you take any sample, okay? You take a sample from here and you analyze that it has 2 molecules of hydrogen, 1 molecule of oxygen. You can take a sample here, it will have 2 molecules of hydrogen, 1 molecule of oxygen. Similarly, this sample you can take anywhere. Chemical composition will not change, it is homogeneous throughout. Homogeneous throughout. So when you take any sample from anywhere in the system and the chemical composition is not changing, it is homogeneous throughout, everywhere. And second point, it is first is homogeneous chemical composition. Second is physical structure. Now what do you mean physical structure? So you see the molecular bonding here. The molecular bonding is also same. 2 hydrogen are bonded with 1 molecule of oxygen. So the intermolecular force, you see, if it is converted to solid, for example, if it is converted to solid, the intermolecular forces will be higher. If you convert into gas, vapor, intermolecular forces will be less. But if you only talk about water, so it will have a consistent physical structure, the molecular bonding, the intermolecular force between 2 molecules, the distance between 2 molecules, it is almost same everywhere. You take any sample from anywhere, physical structure, yani physical bonding between molecules, intermolecular distance, intermolecular forces between molecules, it will be homogeneous anywhere you can see. Okay, so if this is called as homogeneous physical structure. Physical structure means bonding between molecules, intermolecular force, intermolecular distance. So physical structure is called as phase. So if these 2 conditions are satisfied, first is it is homogeneous in chemical composition. First condition is homogeneous in chemical composition. Second condition is homogeneous in physical structure. If these 2 conditions are satisfied, then you can say that it is a phase. Are you able to understand this point? These 2 conditions must satisfy. Homogeneous in chemical composition, homogeneous in physical structure. These 2 things must be satisfied. Then only you can say that it is a phase. Now, there are 3 different phases: solid phase, liquid phase, gaseous phase. Solid phase, liquid phase, gaseous phase. So if I take H2O as an example, so solid phase is what? Ice. Liquid phase is what? Water. That is one phase, okay? This is one phase. This is one phase, because you see, if ice and water will be mixed together, for example, this case, you cannot call it a phase. It is 2 phase, not single phase. Because physical, maybe chemical composition will remain same, H2 everywhere, but bonding between molecule will not be same everywhere. Okay. Similarly, gas is water vapor. So these are all separate phases. These are all separate phases. Okay. Now based upon the phases, the system can be classified further as homogeneous system and heterogeneous system. Homogeneous and heterogeneous system. So what is homogeneous? Homogeneous means A system that has only one phase, For example, you go to your refrigerator. Okay, you have ice tray, right? You go to your kitchen, you fill it with water. So you have this ice tray and you go to your kitchen and fill it with water. So water is filled here. Just water, right? Now this is called as homogeneous because it is just one phase. Now after 3 hours, you go and keep it in fridge, in your refrigerator. After 3 hours, you take out this tray and you see that it is just ice, complete ice. So this is what? This is only ice, means homogeneous. And you wanted to, like make some something, banana shake or something, okay, for you. And you were getting everything ready. So you take out this ice to put it in the mixer and you wanted to make some banana shake or something, cold banana shake. But then someone knocked the door and you forgot to use the ice and you left it in the kitchen. So once you come back after 15 minutes, what will happen is, after 15 minutes, what you will see is, here on the top, we have ice. But here at the bottom, we have water. Yes, on the top, we have ice. On the bottom, we have water. On the top, we have ice. On the bottom, we have water. Top ice, bottom water. Top ice, bottom water. So यहाँ पे we have ice. Here we have water. So these are two different phases. Maybe it is homogeneous chemical composition. This first condition is satisfied, but it is not homogeneous in physical structure. So it is not homogeneous in physical structure. It is a heterogeneous system. It is not one phase, it is two phase. So it is heterogeneous system. Whenever two phases are combined, you will call it as heterogeneous mixture. Heterogeneous. Got it? So this is the difference between homogeneous and heterogeneous systems. When your system consists of only one phase, you will call homogeneous system. When your system consists of two phases, you will call it as heterogeneous system. Okay, very well. So today we have discussed the types of system, and in very detail we have discussed कि first of all, system and surrounding interacts only through mass or energy. Now energy interaction can also be in the heat and work form, but basically the main classification is mass and energy. If mass is not allowed to enter or exit, it is called as closed system. If mass and energy both are allowed to enter or exit, it is called as open system. Now open system can be further classified as steady and unsteady flow. What is steady flow? Whatever is coming in, same is going out. What is unsteady? Coming in is not equal to going out. Either more is coming in, less is going out, or less is coming in, more is going out. So that is unsteady flow. Then we have talked about isolated system. That means neither mass transfer is allowed, neither energy transfer is allowed. And then we have seen, based upon the phase, your system can also be classified as homogeneous and heterogeneous. Okay. Now, phase we have explained. Sir, if it is homogeneous in chemical composition and physical structure, it is called as phase. And if the system consists of only single phase, then it is called as homogeneous. If it is consists of more than one phase, it is called as heterogeneous system. Okay, if one phase homogeneous, system consists of two phases or more phases, heterogeneous system. Okay, so this is what we have discussed. Now in next lecture, tomorrow we will move ahead with this again introduction part. Whatever is left, we will discuss it tomorrow. So I will see you tomorrow. Do not forget to join me at 7 p.m. Thank you very much. Bye bye. ठीक है.